The mass airflow sensor, or MAF sensor, is a critical component in your vehicle's engine system. It precisely measures the amount and density of air entering the engine intake. This measurement is essential because the engine control unit, or ECU, uses this data to calculate the perfect fuel-air mixture. For gasoline engines, this is typically a ratio of about 14.7 parts air to 1 part fuel, known as stoichiometric combustion. Without accurate airflow data, the engine could run too rich with excess fuel or too lean with insufficient fuel, leading to poor performance and emissions. The MAF sensor operates on thermal principles. A heated element cools as air flows past it, allowing precise calculation of air mass. Modern MAF sensors incorporate digital signal processing for improved accuracy and reliability. Many also feature self-cleaning mechanisms or adaptive algorithms that help maintain performance even in challenging conditions like dust or oil contamination. A faulty MAF sensor commonly causes three main symptoms. First, engine hesitation, which is stuttering or surging during acceleration. Second, poor fuel economy, with MPG drops of 10 to 30%. Third, the check engine light illuminating on the dashboard. These issues stem from the ECU receiving inaccurate data, leading to an incorrect fuel-air mixture. Engine hesitation happens when the ECU incorrectly calculates the amount of air entering the engine because of faulty readings from the MAF sensor. This leads to the wrong amount of fuel being delivered, making the engine stumble, particularly when accelerating under load. The result is a feeling that the car is struggling to respond to your commands. A malfunctioning MAF sensor can lead to inefficient fuel use due to either rich or lean air-fuel mixtures. The MAF sensor measures air entering the engine to ensure the proper fuel-air ratio, typically around 14.71 for gasoline engines. Located in the engine's air intake system, the MAF sensor provides data to the ECU for optimal combustion. When faulty, it misreads airflow, causing mixture imbalances. A rich mixture means too much fuel relative to air, leading to incomplete combustion and wasted fuel. A lean mixture has too little fuel, causing engine strain and poor performance. Both result from MAF sensor inaccuracies. This inefficiency directly translates to a noticeable drop in your car's MPG, potentially 10 to 30% lower than normal. For example, a vehicle getting 25 mpg might drop to 18 mpg. The air-fuel ratio chart shows how mixture richness affects emissions and engine performance. Optimal MPG occurs in the stoichiometric range, but MAF faults push it outside this zone. This can cost owners significantly more in fuel, with annual losses of $500 to $1,000 due to wasted gasoline from inefficient combustion. When the ECU detects anomalies from the MAF sensor, it triggers the check engine light. Common OBD2 codes associated with MAF sensor problems include P0100 for circuit malfunction, P0101 for range or performance issues, P102 for low input, P0103 for high input, and P0104 for intermittent failures. Use an OBD2 scanner to read these codes. To diagnose a MAF sensor issue, start by using an OBD2 scanner. Connect it to the vehicle's OBD2 port and check for relevant diagnostic trouble codes. Common MAF codes include P0100 for circuit malfunction, P0101 for low voltage, P0102 for high voltage, P013 for high-low circuit issues, and P0104 for intermittent failures. Next, assess real-time MAF data using diagnostic tools. Monitor live readings to compare against expected values. This helps identify if the sensor is clean, dirty, or bad, providing immediate insight into its condition. Remember that MAF sensor issues can mimic other problems like vacuum leaks. Perform careful differential diagnosis using tools like multimeters to test voltage and continuity. Check for contamination, wiring problems, or related components to ensure accurate troubleshooting. Preventative maintenance is crucial for keeping your MAF sensor functioning properly. Regularly replace your air filter to prevent contamination that can affect the sensor's readings. Cleaning the MAF sensor with a dedicated MAF sensor cleaner can sometimes restore its performance by removing built-up contaminants. However, if cleaning doesn't resolve the issue, replacing the MAF sensor is often the best solution to ensure accurate airflow measurements. Looking ahead, while the rise of electric vehicles may reduce the prevalence of mass airflow sensors, They will continue to play a vital role in internal combustion engine vehicles for the foreseeable future. As EVs gain market share, with hybrids and plug-in hybrids bridging the gap, traditional MAF sensors become less necessary in fully electric powertrains. However, for the billions of existing and new ICE vehicles, accurate airflow measurement remains essential for optimal performance and emissions control. The future brings AI-driven diagnostics integrated into modern vehicle systems. These intelligent algorithms can analyze sensor data in real time, predicting potential MAF failures before they manifest as symptoms, allowing for proactive maintenance and preventing costly breakdowns. From current data, MAF sensor issues account for 5 to 7% of all vehicle repairs, making them a significant maintenance concern. When repairs are needed, average costs typically range from $250 to $500, including parts and labor.